Wasting money on cures. Forgot how to fix myself. They say that time is free. Then why is it so precious? Oh, I'll say memories in my head, like Polaroids on walls. They remind you to look ahead. Time is running out. Time is running out. Lately I've lost my track. I've sailed the deepest seas, hoping to find something to bring back better times. Oh, I'll say memories in my head, like Polaroids on walls. They remind you to look ahead. But time is running out. 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 Time is running. Time is running out. Time is running out. What if my best days are over? They can't be over. They can't be over now. Time is running out. What if my best days are over? They can't be over now. Time is running out. Time is running out. Time is running out.
Good evening, everybody. It's John here from Tutor to You. Welcome you to a very, very special live stream. This is our very first A-level biology live stream. A massive warm welcome to anybody who's joining us live. I'm just looking at the feed here from the chat. Mathilde seems to be very excited to be joining us live. It's lovely to hear from you, Mathilde. Do use the chat window for your answers as the evening goes on. So what are we doing? If you've not watched the Tutor to You live stream before, we've got 30 minutes or so of fast-paced revision activities, and we would love to know what your responses are by using the chat window in YouTube. So please do put your answers in there. They'll be very quick, usually just a one-letter answer. So we would definitely love to see those. At the end of the live stream, we will finish, of course, and you'll be able to download the PowerPoint as well. And this entire live stream is being recorded, so if you want to go through it again, you can do so at your will. And if you're watching this on replay, a very warm welcome to you. Now, I'm here hosting, but I'm not the expert tonight. I am joined by two very experienced, what we like to call it, Tutor to the A-team. We've got Ellena and we've got Tracy. Ellena on my left and Tracy on my right. Good evening to you both.
Hello, everyone.
Ellena, do you want to just give us a little bit of a run through what we're doing tonight?
Yes, so tonight we are going to just split respiration into the 5 main chunks that you all need to know for both your exam boards for AQA and OCRA. So we're going to kick off with some glycolysis. Then we're going to move into the link reaction, see if you know your stuff about that. Off to the Krebs cycle. Then we follow with oxidative phosphorylation, and then we put all that oxygenated stuff behind us, and then finish off with anaerobic respiration. So that is our plan.
Wonderful. All sounds good. We've already got some hellos and things from people who are joining us live. So that's brilliant as well. We'd love to see that continue. Shall we get going with the first activity then?
Yeah, let's do this. Okay, so we're starting off with some multi-choice. So for this first one, which of the following is the correct site of glycolysis? So read it through these answers A, B, C, and D and put your answer on the chat. Let's see what you think. Is the site of glycolysis the cytoplasm of the mitochondria? Is it the cytoplasm of the cell? Is it the matrix of the mitochondria or the stroma of the mitochondria? Okay, the answers are coming in. Okay, yes, we've got a mixture actually of answers there. We've got yeah, actually, we're covering quite a few of them. It was a little bit of a tricky question to start off by the looks of it. So let's have a look at the answer then. Let's see who's right. Yeah, it's B. So well done. Two of you got B. So well done for Veta Malzonia. You got that there with B. It was a bit of a naughty one, wasn't it? Of course, mitochondria doesn't have cytoplasm, so the ones of you who picked A, you were going for your cytoplasm, but you got a little bit put off with that mitochondria. And of course, the center of the mitochondria is the matrix, and the stroma actually belongs to the chloroplast. So no one got sucked into that ruse. So well done. Right, let's have a look at our next question. Okay, so which of the following is the correct description of a step in glycolysis? So think of glycolysis, the steps, the logical order of them. Which one of these is correct? Some of them are not quite right. Let's see your answers coming in for this one now. Oh, it's a bit slower, this one. There were some real quick answers before. What do you think about this one? A, B, C, or D? Okay, Matilda's quick in with B. Okay. Yeah, there's some more Bs coming in. So B seems to be a consensus. Now everyone's going for B. Yes, everyone's agreeing now with Matilda. So that's great. Let's see if Matilda was right. Oh, so it was oxidation, but it was actually oxidation of triphosphate. So oxidation is correct. We are definitely going to be losing electrons by losing hydrogens. But pyruvate, of course, is the final product. It's the triphosphate, that midway down, that gets oxidized and then turned into triphosphate. Oh, yes, realized now. Of course, it's not reduction. It's the coenzymes that get reduced. So that one kills off C. And of course, A is wrong because it's not the triphosphate that gets phosphorylated. It would be the glucose. So again, you're getting used to this now, that you've got to read them quite carefully. So let's see how we get on now. Okay, so which is the correct explanation for why ATP is used in glycolysis? Let's see the answers coming in for this one. Maybe we'll be a little bit slower. Let's see what happens. Okay, yep, we've got some answers coming in. C, yeah, yeah, more C's, more C's, more C's. I think we're being confident again on this one, and I might have just given a clue in the last one as well. So yeah, let's look at the answer for this one. And we've got it now. We know what we're doing. We've got to be a little bit careful reading them through. And yes, it is to phosphorylate glucose. The ATP is dephosphorylated into ADP, an inorganic phosphate, and that inorganic phosphate then phosphorylates glucose. And that is the right one. Now, thinking of the other ones, just why they were wrong. The reduced NAD is made later on when that triphosphate is oxidized. We've already got glucose in the cell, so it wouldn't be the active transport of glucose in the cell. And actually, it's the opposite way around. The phosphorylation makes the glucose less stable, doesn't it? So that is more likely to then split after being phosphorylated into the two triphosphate molecules. So well done. Right, let's see what number 4 gives us. Okay, this is probably quite an easy one. We'll see how you go on that one. I can see everyone's happy now with they're doing so well on that last one. Okay, how many molecules of triphosphate are made when one molecule of glucose enters glycolysis? So how many molecules of triphosphate? So is it A, B, C, or D? Okay, we've got quite a mix coming in here. So this is triose phosphate. We've got one molecule of glucose going in. Think about how many carbon dioxides carbon molecules are in the glucose, and then that might help. Okay, yes, we've got the right answer in there. It is Chatiel, and that, yeah, there we go. That's D is the correct answer. It's 2. So if we think about this for a second, so we've got glucose, 6 carbons. It's phosphorylated. it's still hexose, it's still 6 carbons, and then it splits into 2 pieces, and they are 3 carbons, and they are the triphosphate. So it's actually 2 molecules of triphosphate, and the tri helps us. That was my clue. There was the tri. Was thinking about the numbers of the carbons. Glucose is 6. Tri tells us it's 3 carbons. So well done for looking at that one. Oh yeah, we've got a little bit of a things being noted on the chat there. So well done for engaging with this. It's great. Okay, let's this last one with these ones. So which type of phosphorylation occurs during glycolysis? We've got 4 choices again. Is it oxidative? Is it substrate level? Is it photophosphorylation? Is it direct phosphorylation? So again, a lot of these phosphorylations, they're all true. They all happen in biology, but which is the one which is happening in glycolysis? A mixture of answers is popping up again here. So there, lots of people seem to think it's A, but we've definitely got a B popping in. Oh, yeah, there's a Toby Bale who thinks it's a B, and you will be right. Let's look at the answer. Yes, it is B. Well done. The oxidatives, of course, happen with the ETC later on. That's oxidative phosphorylation. The oxidative there is telling us it needs oxygen. That's a classic error, isn't it, Tracy? For the oxidative
Yeah,
phosphorylation.
absolutely. So guys, we're moving on now to our second section. So this next section is going to be all about the link reaction. So this is our little reaction. Some might say this is one of the easiest parts of respiration. Well, let's see how you do. So what we've got is our true false game. And here's our first one. Decarboxylation.
I think we've just
Oh, we
lost
seem
sound.
to have.
Oh no, we're back again. We're back again. I'll jump away. We're all good.
I think what we'll do is, I think there
Okay,
seems to
let's
be
see the answer for this.
there's a
one.
little bit of a problem with Tracy's feed, so we're just going to get her to rejoin us. Ellen, will you be okay going through this first question
I'll just
while
take
we're
over
waiting
while
for
we sort
Tracy?
out
Yeah.
the technical issue. I'll go for this first. Yes, that's great. So we've got true or falses here. So we're now into the link reaction. So true or false for this one. Only 2 to choose from. Decarboxylation and dehydrogenation of pyruvate occurs. So let's see what we've got on the chat there. So we've got, yes, we think so. Some people are thinking it's true. Yeah, it's a hard one. So I'm just waiting for some more answers to come in here. Yeah, it's 50-50, guys. Come on, that's just, what are you going to do? We're having to phone a friend. Someone don't know. Well, why don't you pick on one? Some think it's false. Actually, there's a big mix. Let's have a look then. What do we think? So this one is indeed true. So if we break that one down a minute, we have the link reaction, and we have it starting with pyruvate, and pyruvate is going to have some carbon dioxides removed, so that's decarboxylation, and it's also going to have some hydrogens removed as it's oxidized, so that's dehydrogenation, and that ends up being acetyl coenzyme A. So well done for those of you who got that one right. Let's see another one. Okay, another true or false. Pyruvate is oxidized to acetate, or some might know it as an acetyl group. Is that one true or false? Let's have a think. Let's see what we've got. So some people are thinking this is false. I can see coming up. Any other ideas? Yeah, so it was true and false. We've got both coming up. Let's see what the consensus is. So real mixture here. Let's see what we've got then. Let's see what the answer is. And this, of course, is indeed true. So the pyruvate is oxidized because the hydrogens are removed, and therefore it's losing those electrons that are found in those hydrogen atoms. So the pyruvate is oxidized, and it's oxidized to acetate, which is then accepted by the coenzyme A to become acetyl coenzyme A. So you might think of it as the acetate being accepted by the coenzyme A and carried, or you might know it as an acetyl group. Either which way, that one's true. Let's do another. Okay, true or false? Is reduced FAD made in the link reaction? True or false? Yes, that's it. Believe, Mathilde. Let's get the next one. Mathilde, what are you going to do there? Okay, we're looking strong on this one, Mathilde. I agree. Let's see if everyone else agrees with you. Yes, I think, okay, look, we're feeling much happier about this one. Let's see this one. Yeah, we all think it's false, and we know it's false because we know that reduced FAD is made in the Krebs cycle, not in the link reaction. So that was a solid one. Well done, everyone. Okay, let's do next. Okay, true or false? This is the link reaction, remember. Does substrate level phosphorylation occur? What do we think? True or false? Is that happening in the link reaction? Yeah, we've got answers coming in. Yep. Okay, it's looking good, this one. Okay, very, very good. Yes, let's see if everyone agree. Yes, it's false. Absolutely. So substrate level of phosphorylation does happen in the glycolysis reactions we've just been talking about, and it happens in another one, but which we're going to come on to, but no spoilers there. But it does not happen in the link reaction. So well done getting that one straight. Okay, last one of these true or falses. This is going to be a straightforward one. I've probably given this away along the way. Acetyl coenzyme A is made. Let's have a quick flurry of answers on this one. And Tracy, you're back with us.
Looks like Tracy's back. Hello, Tracy.
Yay!
Yes,
Brilliant.
hello.
We're just about to reveal the last answer of the true or falses. I'm going to hand over
Wonderful.
to you for this one. So just to let you know on the chat, you've missed that people are thinking this is true. So I'll hand over to you for the last reveal.
Okay, let's have a look then. What have we got? Is it true or false? Yes, well done, everyone. And for you AQA bods, you know that you never abbreviate acetyl coenzyme A to acetyl CoA. Okay, so be aware of that one for AQA. They're really strict on some abbreviations, aren't they? And this is one that is not allowed. Okay, brilliant. Well done, everybody. Moving on then.
Yeah, I'm just going to jump in with a quick reply to one of the chats. So one of now who is this then? So we've got Jupiter Hay said, how does the acetyl group become acetyl CoA? So we've got coenzyme A, and a coenzyme is just like a shuttle bus. It's just grabbing, maybe it's a group of atoms or some atoms, and it's taken from one place to another. So coenzyme A just takes the acetate or the acetyl group, and whilst it's carrying it, we just call it acetyl coenzyme A. So I agree, it's a bit of a misleading name, and this actually leads to misconceptions and misunderstandings. So coenzyme A doesn't carry acetyl, it carries the acetyl group or acetate. So that was a good one to query. I think that's, oh yes, and there was another little question from Mathilde. Are we allowed to abbreviate triose phosphate? That is a very good question. So for the AQA lot, it's an absolute no. They will not give you the mark. They're meanies. So you must always write out the name in full, and then you can call it TP if you put that in brackets afterwards, and then you can use your abbreviation. Now for OCR, I would always encourage you to write it out full just once in the same way. But if the command word says name the molecule, then whichever exam board, you have to write it out in full. So don't just know your abbreviations, know the full name as well. So we've nailed glycolysis, we've nailed link reaction. Let's move on to the Krebs cycle. So in this activity, we have a rainy day today. And what we've got to do is we've got to put up our umbrella and think of which of these are correct for events that happen in the Krebs cycle. So there's a timer for this one. So let's set that timer going and see if you can put all of the correct names under the umbrella. Write them out in the chat as you're thinking of them. Yeah, just use the numbers. So if you think one of them's correct and you think it's number 1, stick number 1 in. Or if you think it's 2, stick 2 in. Just put the numbers and see how many you think of those are correct for the umbrella. Okay, well done. You've been very active on the chat. It's great to see. So a whole spread of different numbers. Let's see how you did. Let's see which ones were correct. So It's definitely oxidation reduction reactions. In fact, the whole thing is just oxidation reduction, oxidation reduction. All of those substrates, intermediates of the Krebs cycle, are being oxidized, and then the coenzymes NAD and FAD are being reduced, which means number 4 is also correct. It will be reduced NAD, that reduced coenzyme that is made. It is a 6-carbon molecule that is produced. OCR will know that as citrate. AQA don't need to know it as citrate, just it's an 6-carbon molecule produced. And that's when the 4-carbon molecule, OCR will know it as oxaloacetate, reacts with the acetyl coenzyme A, delivering that acetate group. 4 plus 2 makes 6. That's our 6-carbon molecule. And we can do a bit of maths here, and we know that if we've got 6 carbons and it has to be a cycle and get back to 4 carbons, it needs to lose some carbons. How does it lose those carbons? CO2 is lost. So this also involves some decarboxylation reactions. Why are the ones above incorrect? Pyruvate is produced. No, that is all the way at the end of glycolysis, if you remember. So it's nothing to do with pyruvate now. The reduced NAD is oxidized. It's the other way round. Its NAD is reduced. Reduced NAD would be oxidized later on in oxidative phosphorylation. Bit of a spoiler for that. So it's not oxidative phosphorylation, and ATP isn't used here. This is the other example of substrate-linked phosphorylation where ATP is made in the Krebs cycle. I've got a question here on the chat. Does reduce, this is from Matilda, well done for asking all these questions, Matilda, it's really good. Does reduced in this case mean gain electrons or lose oxygen? So it's always oil rig. Oxidation is always loss of electrons. Reduction is always gain of electrons. So the intermediates of the Krebs cycle are losing electrons, so they're oxidized, and they are giving them to the NAD and the FAD, which become reduced. So it's always, we call them redox reactions, reduction oxidation reactions. They always go hand in hand. That's yeah, no, you're welcome, Matilda. So this is me handing over to Tracy for your next game.
Great. So we're on OXPHOS here, or in other words, oxidative phosphorylation. And we've got a 60-second challenge for you. So this has got to be quite quick at this one. We're going to have a set of processes or locations on the left. You can see that with the letters A to F. And we've got to match them with the description on the right, which is the number. So we can start the timer, and then you can just bung in the chat the letter with its associated number there. Let's see what starts coming in. So just put them in the chat as you go along here. So we've got some that are going A's first with 4. Yeah, that's looking quite promising. Some people starting with the numbers. I can see we've got a 1. Some people are going for E. Some people are not so sure. Something different. I'll let you have a little read and a little bit of peace now for the last 25 seconds. Right, let's see how you did. Maybe the 60 seconds was a bit tough to get them all read and matched up. So let's have a look at the answers now. Okay, so I'm going to start going down the letters, the left-hand side, and matching it up. So we've got chemiosmosis there, and that is all to do with the movement of these protons, our hydrogen ions, okay? And that's linked to the making of ATP. That is what we are producing in chemiosmosis. Really important thing to note. When you are writing H plus, don't forget that plus. It's so easy under exam conditions to just start putting H, and you will not get the mark because H is, of course, the atom and doesn't refer to the proton or the ion version. So be really, really careful that you make sure you get that superscript plus in, okay? Okay, so B, the intermembrane space. What's that all about? Well, that's really important, isn't it? It's the site where we've got our accumulation, our buildup of our protons, okay? So we've got our proton gradient being created there. Okay, moving down to C, electrons moving to a lower energy level. Okay, that's all about the release of energy. Another key exam tip here. We don't want to create energy, okay? That's not happening. That defies the laws of physics. So that little phrase, the release of energy, really important that you use that phrase, exact phrase there, okay? Exam boards, all of them prefer release of energy. Let's not be producing and certainly not creating energy. All right, so let's move on down now to ATP synthase. What's that all about? Well, that is, of course, our stalk particles, some of you might know it, causing the reaction of ADP and PI. In AQA, you are allowed to abbreviate those. They are listed in the specification in those abbreviations, so that's always fine, isn't it? Okay. And facilitated diffusion, that's often a 1-mark question. So learn the process by which the transport takes place as well is a really good exam tip there. All right. So our last two now, we've got E, reduced NAD and reduced FAD. These are going to release their hydrogen that they've been carrying, aren't they? And so they are then becoming oxidized when they release that hydrogen, all right, at the start of the electron transport chain there. Again, for AQA, you're not allowed to abbreviate that one, so look out for that one, okay? And last of all, oxygen. It is, of course, our final electron acceptor, which a lot of you, I think, did actually get right. So brilliant. Well done. Handing over to the final section now.
Hello again for the final section. I do want to just jump in to answer Matilde. You're awesome tonight with your questions. I love it. So you say we can only ever make ATP, never energy, and you are absolutely, you've nailed it. We can make ATP because it's a chemical, it's a molecule. So that's awesome, but we can't make energy. Mr. Einstein gets very upset. He will turn in his grave. We cannot be creating or destroying energy. We can only change it from one form to another. So well done on that one. And you are quite right with your ATP, adenosine triphosphate, and unfortunately that means you triggered my joke. So all us biologists have jokes, and I'm joke warning now. So a man walks into a bar and says, I would like a pint of adenosine triphosphate, and the barman says, that'll be ATP, please. If only a pint was ATP. Anyway, moving on to the final activity. So lastly, we are jumping into anaerobic respiration. This is our lovely bubble quiz. I love the bubble quiz. This is a little bit more tricky than your normal multi-choice quiz because it could be all of them right. It could be all of them wrong, or anything in between. So you've got to have your wits about you for this one. Let's see the first one. So, which of these would not occur in anaerobic conditions? So think anaerobic, anaerobic, anaerobic. So which of these would not occur in anaerobic conditions? Have a think, put your choices in the chat. What's going on for this one? Let's see. Okay, no one's sure. This is tricky. No one's been brave. Come on, let's have something. Okay, here come in the answers. I can see them coming in now. So thinking B and D, yeah, you're on the money there, Carrie. Yeah. Toby Bell thinks all of them. So let's see what the answer is. And you'd be right. Well done. Of course, it is all of them. These all have to have oxygen. Oxidative phosphorylation has to have oxygen, the final electron acceptor. And of course, chemiosmosis is oxidative phosphorylation. So those two go together. And without oxygen as the final electron acceptor, the coenzymes reduced NAD and reduced FAD are not oxidized. So NAD and FAD can't go back to the link reaction and the Krebs cycle. So they can't continue. All of the processes in the mitochondria stop when it goes into anaerobic conditions. So well done there. Nice job. Okay. So which of these figures is the correct number of ATP made in anaerobic conditions when one glucose molecule is respired? So what do we think of these numbers? Did I make any of them up? Are they true? Are they false? Okay, Matilda's straight in there thinking C. Does anyone agree with her? Oh, no one else has been brave. Okay, so we've got B and C being chosen. Yeah, well done, Toby. The net bit, what does the net bit mean? I'll tell you now. Let's look at the answers. So it is B and C. Well done. You got them right there, Toby. So B is definitely correct because 4 ATP molecules are made when one glucose molecule is respired through glycolysis. However, what is this net business all about? We have to, if you like, spend 2 ATP doing the phosphorylation step at the beginning. So 2 ATP molecules are used to phosphorylate the glucose. So actually, you make 4, you use 2, you've done a net gain of 2 there. For anyone who's got a job, you guys won't have to pay tax yet, but when you start paying tax, you'll know all about gross and net and how much you've got left over once you've spent some. So the net thing is quite important here. The other 2 numbers are aerobic numbers, so definitely not without oxygen. Okay, let's do number 3. What happens to pyruvate in anaerobic conditions in mammalian muscle cells? So what do we think of this one? Is the pyruvate decarboxylated? Is it oxidized to lactate? Does it accept hydrogens from reduced NAD? Or is it reduced to lactate? Which ones are those, or if any? Or okay. Okay, so Matilda's straight in there with C and A. Anyone else? Okay, we think D possibly. So what is it going to be? Tricky one. Not sure, but we're thinking maybe B. We're maybe thinking DNA. Okay, so we're all over the place with this one. Let's see which ones are actually the correct ones. It is C and D. So this is where a lot of confusion can arise. So it's definitely not decarboxylated because this is the mammalian muscle cells. So the pyruvate is just converted into lactate. It's a one-step reaction, no CO2 lost at all. So if it's aerobic respiration, of course, pyruvate is oxidized. But if it's anaerobic like here, pyruvate is reduced to lactate. So I like to talk about the reduced NAD. It's carrying its hydrogens and it's just made those from glycolysis. Glycolysis is the only thing that's still working and it's got these hydrogens. It's got to dump them somewhere. So this is all about hydrogen dumping. Where do I dump my hydrogens? So in the mammalian muscle cells, the reduced NAD dumps its hydrogens on pyruvate. So pyruvate accepts hydrogens from reduced NAD, and because it has accepted those hydrogens, it's gaining those electrons, so it is being reduced to lactate. So they go hand in hand. Right, we're nearly at the end now. Let's do 4. What happens to pyruvate in anaerobic conditions in yeast cells? Let's see what your choices are there. Okay, we've got all straight in there, D with Matilda. We've got C and D. C then D. I see where you're going with that one. So we've got D there. So we like this idea of ethanol. Let's see what we've got. So I was being a bit sneaky with this one because actually what happens just to pyruvate in anaerobic conditions in yeast cells happens to be decarboxylated first. So the carbon dioxide is removed and that converts it to ethanol. And it's only when it accepts the hydrogens, that's the hydrogen dumping for the second step of this reaction. The ethanol accepts those hydrogens from reduced NAD and that converts it into ethanol. So ultimately, you are correct. It will finally end up as ethanol. But actually, what happens to pyruvate is it's converted to ethanol. So yes, I know it's sneaky. I know. Right, let's do our finale here. Last question for the day. Okay, lactate and ethanol fermentation release oxidized NAD, which is needed for what? So what is that oxidized NAD needed for? Is it needed to release hydrogen for the ETC? Is it needed to reduce triphosphate in glycolysis? Is it needed to reduce pyruvate in the link reaction or reduce the intermediates in the Krebs cycle? I might be very sneaky here, so I'm warning you. Sneaky, sneaky. Have a good think. There's some subtleties. Yes. Uh-oh. Yes. Uh-oh. It's a bit naughty, this one. Okay, Matilda. Let's see if you're right. Yes, you are. None of them correct. How bad am I? So, of course, this is anaerobic conditions. So there won't be any ETC because that's oxidative phosphorylation. There won't be any link reaction or Krebs cycle because that's also needs oxygen. So that's not happening. And it's a bit naughty with B because if you go back to our very first activity, we're not reducing triphosphate in glycolysis, we're oxidizing it. So that's a little sneaky error in there. You've really got to be on your game. But thank you so much for enjoying this evening. I've definitely enjoyed it, and your comments are just so lovely. So thank you very much.
Absolutely, absolutely. Can I just say a massive thank you as well to everybody who's joined in the chat window tonight? It makes these live streams go a lot quicker and more interesting if we've got people who are actually participating in it. Thank you so much. And we will be back next week, Ellena. We're back again for to have a go at a different topic. What are we on next week?
So next week it's photosynthesis.
Photosynthesis.
Yeah, check out our plan for the run up to Christmas. We're going to be doing lots of different topics. Get you ready for your mock exams. We're here for you.
Just a quick reminder, of course, that this is the PowerPoint that we have been using tonight will be available to you in about a minute's time, and this has been all recorded, so you can go over it again and watch through again. A massive, massive thank you right at the end, of course, to Ellena and Tracy for delivering those questions, the easy ones and the sneaky ones. Thank you for all of those, and we look forward to seeing Ellena, Tracy, and of course everybody who's been watching at the next live stream next Tuesday. If you found tonight useful, please do give us a thumbs up in YouTube. That helps get our message out there. We hope to see you again very, very soon. Goodbye, everybody.
Bye.